All right, so we're now moving on to the last few sections before the end of the term, which is also the end of the semester. So this is your last test that you have if you want to improve your grade or if you want to keep your grade where it's at and you don't want it to fall. So you really need to work hard on these last few sections. All right, so make sure you are doing all your work, you're watching these videos, you're taking notes, you're asking questions if you need it. All right, but we are continuing on to Chapter 8, and we're now moving on to Section 8. And we're going to be talking about the equation of a line. All right, now there's going to be two different equations that we're going to talk about in detail, and we're just going to talk about the characteristics of a line as well. So our objectives for today, what you need to know from this video, is you need to understand the characteristics of a line. You need to be able to rewrite from standard form to slope-intercept form and vice versa, meaning from slope-intercept to standard form. And then you also need to be able to determine if 2 points fall in a line. So those are things that you have to be able to know from the end of this video. All right, so first off, let's go ahead and draw a line. I'm going to use different color, and let's just go ahead. All right, so there's a line that I drew. Now, remember, there are already some things that we talked about this line. We talked about our slope of a line, or the gradient, and that tells us the steepness of our line. It's telling us how much our line is increasing or decreasing as we move along. So is it going to be rising quickly? Is it going to be falling quickly? Is it rising slowly, falling slowly, etc.? And we learn, let me just fix it. And we learn that one of the things that we could do is if we found where this graph crossed our box, the corner of our box, in 2 different points, so it crosses there and it crosses here, we can figure out our slope by counting up. That's our change in y, counting over change in x. So according to this, our graph, our slope will be equal to, it moved up 2 spaces and over 3. So it will be 2 over 3. All right, but that's something that we have already discussed, already gone through. There's just a few things that I do want to talk about in regards to a line. All right, so there's some key points that you need to know what they are. This point right here. All right, we will discuss this in further detail, but this point right here is called our Y-intercept. And the reason why it's called our Y-intercept is because it is intersecting our Y-axis. That's where our graph crossed our Y-axis. The other point that we're going to be discussing in further detail is this point here. And if where we crossed our Y-axis is called our Y-intercept, well, this is our X-axis, so that is going to be called our X-intercept. All right, we will discuss those in further detail in the next video, but it's something that you need to know. And also, another thing that you need to know is this line, by drawing these arrows, it's telling you that it goes to infinity, that we could draw this line and keep going in the exact same steepness using our same slope as long as we want. It's saying that the line never ends. It goes to infinity. All right, and then the last characteristic that I want you to know about this line is if I take any point on this line, all right, so I knew this point here, I can say what point this is equal to by looking at our graph, because that is at our 3 for x, so that would have an x value of 3. And our y value we could say is 1, 2, 3, 4, 5, 6, 7. So it has a point of 3, 7. I could take this point here. My x value was we're moving to the left, so it's -1, -2, -3. And my y value, 1, 2, 3. So then my y value is 3. So I can take any point on this graph, and it doesn't have to be a whole number. I can take any point, and that is generating an x and a y value. All right, so anytime if I say, does this point fall on a line, if you're given a graph, you can just look at the graph and say, does it actually fall on it? Or you can plug it into the equation, which we're going to do in a minute. But just know that at any point, if I were to take any point on this line, it will generate an x and a y value because we're moving along our x-axis, left or right. Remember, as we're moving right, it's positive. So 1, 2, 3, 4, 5, 6, 7, 8, 9. As we move along our left, it's negative, just like a number line, -1, -2, and so on. When we move up for y, though, it's positive. So it will be positive 1, 2, 3. And as we move down for y, it's negative, -1, -2, -3, and so on. All right, so some of the key things that you have to know about a line are, 1, the x-intercept is where it crosses our x-axis. The y-intercept is where it crosses our y-axis. We need to know our slope, which we've already talked about, and that's telling us how quickly our line is rising or falling. It's telling us the steepness of a line. And then you also just need to know that at any point, if you're given a graph, you can take points off of that graph as long as if it falls on the line we know it's part of that graph. So we can say, okay, we can use this 0.37 or this point -33. All right, you guys follow me with that? All right, so now let's go ahead and move on to some of the questions that you'll have to do and be able to do for homework. If you were confused about this the first 10 minutes of class, we're going to go over any of the questions that you have for this. But those are some key characteristics of a line that you need to know. It's x and y-intercept, its slope and steepness, and at any point that I take off of the line, it's going to give me an x and a y value. All right, so as I was saying, the equation of a line is a rule which connects the x and y coordinates of all the points on the line. So as I was saying before, we can take any point off of our graph and generate an x and a y value. So an equation of a line now is a rule that connects all of our x's or y's. So it's giving us an equation that we can follow, and then we can use that to determine all of the x and y values that we possibly could have, or to determine if an x and y value given to us, if it falls on the line. All right, so there are two equations of a line that you need to know from this section. And the first one, I'm going to refer to it as standard form all the time. Your book will refer to it as general form, so just know that standard form, general form are the same. Your test will have standard form on it though. All right, so your standard form is ax plus by is equal to c, where a, b, and c are integers. So that means they got to be whole numbers, because if they're fractions, we would rewrite it to give us an integer. But a, b, and c are integers, and a, b, and c are numbers, obviously, because they're integers. All right, so we can substitute any values that we want for ax, or for a, for b, and for c. X and y will always remain x and y, because we can make sure that we can plug in any numbers for x and y. So an example of a standard or general form is 4x plus 6y is equal to -8. All right, so here our a would be equal to 4 because it's what's in front of our x. Our b will be equal to 6 because it's what in front of our y. And our c is equal to -8. All right, and our c in this case is a constant. Our c is a constant. But in general form, it's written as ax plus by is equal to c, where a, b, and c have to be integers. All right, I'm going to erase this because clearly they have to be numbers when they're integers. And c is constant. All right, so in general form, it's ax plus by is equal to c. Now, in our slope-intercept form, we would take this standard form and we would rewrite it so that y is equal to. So in our slope-intercept form, it is y is equal to mx plus b. Right, now, we should already know what this letter m represents and what it's equal to, and that is our slope, because we've already done that in our last section. We've already took a test on. I told you to be using the letter m to denote slope. So we know that this number here in front of the x is going to be representing our slope. This a does not represent our slope because in this case it's not set equal to y. Right? So in order for us to say that the number in front of our x is equal to our slope, we need to have y isolated and all by itself. So in this case, so when it is isolated to our y, the m, the lowercase m, represents our slope. And then this b represents our y-intercept. Right? So we are going to discuss this in further detail in the next video, especially when we're graphing, and then in the next sections after that when we're solving for a linear equation. All right, but just note that this letter B represents our y-intercept, and as we've already discussed, that tells us where our graph crosses our y-axis. All right, so the first couple of questions we're going to do is we're just going to have an equation given to you in standard form, and you'll have to rewrite it in slope-intercept, and then vice versa. We'll give you one in slope-intercept, and you have to rewrite it in standard. All right, so for this one, if we want to rewrite it in general form, remember, general form was ax plus by is equal to c. So that means our a and our x's were on one side of our equation. So if I want to rewrite this in standard form, the first thing I'm going to do is I'm going to add this 1/4 x to both sides so that I have my x and my y on one side of the equation. Like it needs to with the standard form. Now, if you recall, the next thing I said is a, b, and c had to be integers. Let me get rid of z because I don't know if you know that, but they have to be integers. So if they have to be integers, they need to be whole numbers. Well, we have a fraction 1/4 and 3/4. They're not whole numbers. So if we want to change these into integers, it's exactly what we did earlier in the year when we have rational equations, is we look at all of our denominators and we find the least common multiple or the least common denominator. In this case, it's 4. And just like we did earlier in the year, we will multiply everything by that 4 because we know since it's an equation, if I multiply everything by 4, it's not going to change its value. Well, this 4 and this 4 will cancel, so we just have an x. We don't have anything to cancel with this 4, so it becomes 4y. And these 4's cancel, so it's equal to 3. So this is our general form. We can rewrite y is equal to -1/4 x plus 3/4 as x plus 4y is equal to 3. Where an a is equal to the number in front of x, so that would be 1. My b is equal to the number in front of the y, so that's 4. And my c is the constant all by itself, 3. All right, so now we are given one in our standard form when we need to rewrite it as our gradient intercept form or slope intercept form. And we know this one is y is equal to mx plus b, so that means we need to isolate our y. We need to set everything equal to the y. So since our x is on the left-hand side, I'm going to subtract the x to move it to the other side. So 5y is equal to -2x plus 7. Right? And then we need to get y all by itself. There's not a number in front of y, it's just y. So I need to get rid of this 5. So I divide everything by 5. That isolates my y variable. All right, but now the one thing that you need to do is when you are writing it in slope-intercept form, you are going to create 2 separate fractions. You will create one here, so then you have y is equal to -2x over 5. And then you will create another fraction with the number on the outside. So that will then be plus 7 over 5. All right, we want to separate these. We don't look at these as one because now by doing this, I know that my slope is a number that's being multiplied to my x. So that is this -2 over 5. And then I know my b is the constant that's being added on the outside. So it's whatever's being added. So in this case, my b is equal to 7 over 5. All right, so by separating the fractions, we can simplify fractions if we have them. Or we can look and see exactly what our slope is and exactly what our y-intercept is. So you will never leave it as that one fraction. All right, but just remember, it creates 2 separate fractions because this -2x is being divided by 5, and so is this 7. All right, so now it says points on a line. So a point lies on a line if its coordinates satisfy the equation of a line. So remember, I already gave you a line earlier, and we were able to look at the graph and say, okay, well, this generated the point 3, 7. However, a lot of times you're not given a graph. A lot of times you're just given the equation because the equation is easier for us to work with. We can then substitute in for our x values to determine what will happen with our y. So it's easier for us to do, and it's how you deal with a line majority of the time. So usually you're not looking at the graph to say, okay, let's take points off the graph. Usually you're given an equation and you're asked to determine, is this part of the graph? And it's very easy. What it needs to do is it just needs to satisfy, meaning that when we plug it in, it still gives us a true equation. It just satisfies the equation of a line. All right, so we have a couple of these to do real quick. So for A, it says, determine if 3, 7 lies on the line of the equation y is equal to 2x plus 1. So it's really easy. We have the point 3, 7. Remember, in our ordered pairs, we've already discussed it's written as x, y. So that means we will substitute 3 in for x. So it's 2 times 3 plus 1. And then we substitute 7 in for y. And what we're doing, we're seeing, does this equal? So I like to put the question mark above the equal sign. So I remind myself, I'm asking, is this equal? So then I simplify. So 7, does this equal to 6 plus 1? Well, 6 plus 1 is 7. So 7 does equal 7. Check. Yes, it falls on the equation. All right, so let's go ahead and try the next one. The next one, we have the points 4 and -2. And now we have it in standard form, 5x plus 3y is equal to 16. If we're trying to see if these fall in the equation, well, we're going to substitute them in for x and y. So it becomes 5 times 4 plus 3 times -2. And then I'm asking, does this equal to 16? Well, 5 times 4 is 20. 3 times -2 is -6. Does this equal to 16? Well, 20 minus 6 is equal to 14. And 14 does not equal 16. So no, this does not fall on our line. So we know that 3, 7 is part of our, is on our equation. If we were to graph this equation out, it would fall on our line, whereas 4, -2 does not fall in the line that we have 5x plus 3y is equal to 16. All right, so by if it satisfies, meaning it gives us a true equation, 7 is equal to 7, that's true, then we know it's on our line. It's part of our graph if we were to graph it out. If it does not give us a true equation, so it gives us a false one, then no, it's not part of our line, so we can't use it. We can't use that to say it's part of our graph or part of our line. All right, now the last thing that we're going to do are these two questions here. I realize this video is getting very long, and I apologize for this. I kind of just rambled on a lot of this. But it's very important. I'm hoping that you guys understand the characteristics of a line to make things easier in the future. All right, this is extremely important. Our section that we're going to do, not next, but the one after that, if you find this easy, then that section is going to be easy for you, and that's typically the one that people find hard. All right, so what it's asking you to do is it's giving you this point. It's saying given that -5, -2 does lie on the line. So that means if it falls on the line, we know it satisfies the equation that we have. And now what we're trying to do is we're trying to solve for this missing variable, c. So we know that we have -5, -2, and we know that -5 is an x value and -2 is a y value. So we can substitute that in. -2 is equal to 4 times -5 plus the c that we don't know. I don't have to put the question mark above it because it tells me it lies on the line. So it's telling me it satisfies this equation. Now I just have one unknown. It's very easy. We solve for it just like we would have in chapter 1. So -20 plus c, because -5 times 4. To isolate our c, we will add over the 20. So then we get that 18 is equal to c. All right, so now one of the things that you will have to do in the future is we don't ever leave our y-intercept or our c as a variable. We plug it in as a number. So we would give this as a final answer, 4x plus 18, because that's what c was equal to. And we just substituted 18 back in for the c. All right, for the next one, we have 3x minus 2y is equal to k. We're given that the points 4, 7 fall on the line, so I know that they satisfy this equation. So I can substitute 4 in for x, so 3 times 4, and 7 in for y, so -2 times 7. All right, just like before, I don't have to write the question mark on top because I know it satisfies it. And then I just solve. This will give me 12 minus 14 is equal to k, and that means -2 is equal to k. All right, so one of the things that you have to get used to and good habits is later on, right now, it might not ask you to do this, but later on you will need to write it back in as -3x minus 2y is equal to -2. All right, so you will have to rewrite it, and that's something that you need to be able to do in the future. All right, that is it for this video. I apologize for it being so long, but it's important that you understand the characteristics of a line.